Good evening, everyone. It's a pleasure to welcome you all to the inaugural session of SparkLink 1.0 on behalf of the IEEE student branch of University of Rohini. As you all are aware, SparkLink 1.0 is going to be conducted in two phases, where the first phase will be focusing on electronic design, while the second phase will be focusing on advanced digital design. Altogether, there will be 5 workshops before moving to the competition phase, and the competition will be conducted in physical mode. What's important is that all the participants who complete 4 quizzes out of the 5, which will be provided at the end of each workshop, will be awarded an e-certificate. In addition, all the participants in the competition will be given an e-certificate too, and the winners will be given valuable cash prizes. Thus, we are commencing the first phase of SparkLink 1.0, which will have 3 workshops on the 12th, 13th, and 19th of August. I would like to remind you that at the end of each workshop, you would be given a 10-minute quiz as an evaluation of your progress. And there would be a Q&A session at the end of the workshop as well. There you can raise your problems to our guest speaker. Without further ado, I would like to invite Mr. Pathum Malavarachi, co-chair of SparkLink 1.0, to deliver the welcome speech. Pathum, it's over to you.
Thank you, Uma. Good evening, ladies and gentlemen. In a world where technology is evolving very fast, staying ahead requires more than just theoretical knowledge. It demands practical skills, insights from industry experts, and the ability to adapt. SparkLink 1.0 is your opportunity to gain all of these and more. Our workshops, led by experienced professionals, will not only expand your understanding of electronic design, but also ignite your creativity. I am absolutely delighted to extend a warm welcome to all the esteemed participants who have joined us for the Phase 1 Electronic Design Workshop. Every year, a fresh wave of engineering undergraduates steps into the industry, fueled by passion and armed with knowledge in their chosen domains. However, the demands of the industry are dynamic and ever expanding, requiring continuous upskilling and exposure to the latest developments. This is where the initiative SparkLink 1.0 comes into play. So, it's an honor to introduce our resource person for today, Mr. Hasitha Gunawardhan, a final year undergraduate from our beloved Faculty of Engineering, University of Rohini. Despite being in the final year of his undergraduate studies, he has already shown exceptional dedication and expertise in the field of electronics. With a passion for technology and a dedication to pushing the boundaries of knowledge, he has become a shining star within our academic community. Having actively contributed to prestigious international events, he has demonstrated a profound dedication to innovation, problem solving, and the boundless possibilities of space technology. Your presence truly enhances the spirit of this workshop, and we are grateful for the knowledge and inspiration you are about to impart. So, I encourage each and every one of you to actively immerse yourselves in the workshops, ask questions, and make the most out of this enriching experience. Once again, a warm welcome to all of you. Over to you, ma'am.
Thank you, Pathum. Today, as Pathum said, we have a special guest speaker whose passion is electronics. Let me introduce Mr. Hasitha Gunawardhana, a final year undergraduate from our esteemed Faculty of Engineering, University of Rohini, President of Electronic Circuits at EIES of University of Ruhuna, and the chapter coordinator of IEEE Ruhuna chapter. I'm pleased to invite Mr. Hashitha Gunawardana to continue the session. Over to you, sir.
Okay, good evening. Thanks for having me. Am I audible?
Yes, you are, sir.
Okay, thanks. In this session, since I only got 1 hour, so I will first touch into the basics of electronics, maybe in 20 minutes, about basic components, and then I will be going to introduce how you can select a component for your required task, considering the circuit requirements. So this is basically done to address your competition at this end of this workshop series. Okay, so let me share the screen. So Patum, screen share is disabled. Patum.
Yes, give me a minute. Check it. Maybe you can.
Okay, now so. Okay, can you see the screen?
Yes, we can see.
Okay, thank you. First, we are going to basic electronic components. So as you all passed the A-level exam, I know you have a basic understanding of about this. So I will not read all this information one by one. So that will be very boring. So I will be highlighting only the important things. So first, if we go to the electronic circuit components, so the first and most simplest electronic component is the resistor. So only a resistor may appear like this, or there will be many forms of form factors of resistors. So all the resistors. So someone is drawing on the screen. Okay. So all of these resistors basically have two leads, and what is a resistor is the resistor is a component that resist the flow of current. So if we want to control the flow of current in any path of a circuit, so we can use a resistor. And when we consider when we going to choose a resistor, we have to consider first the resistance value, and additionally, if we are going to control a large amount of current, so we have to consider the voltage of the resistor as well. So you know about the color coding, so you don't have to remember this. So you can just Google the color code and use it. So okay, so you may already know about these type of resistors. So there are various kind of resistors. So these types are 5 volt resistors. So the voltage of resistor is how much thermal, like temperature this this resistor can withstand. So there are half watt, 1 watt, 2 watt, 5 watt, 10 watt, and so on. Like higher voltage resistors like this resistors are this big white resistors are 5 watt. So there can be 10 watt or 20 watt resistors. So you know what is the equation for calculating power. So according to that, we can P equal V multiplied by I. So according to that, we can select what is the what value we want. So for your task, that this will be not very important. But if you want to handle a large amount of current, so this what value also should be considered. Otherwise, this resistor will burn out. Okay, then the next one is the light dependent resistor. So you have, I think you have played with this component. So it is like light sensitive resistor. So if light is available, so the resistance between these two terminals will be reduced. So there will be more current flowing through this resistor. So then capacitor. So capacitors are there are basically two types: polarized and non-polarized. So this polarized, non-polarized capacitors, as the name suggests, there are no polarized, like there are no plus and minus terminals. So you cannot see any it is marked here. So this also have two leads, and the functionality of a capacitor is to store the energy as a static or electric field. So I think you have learned about the capacitor as well in the A-level years. So the unit of capacitance is farad. So since this is a very large value, so we have various form factors, micro, nano, pico, and so on. So then this you may also know about this. So to read the capacitor value, so like there's a code here, like in here 103. So we can get the capacitance value like 1, 0, and 3 zeros. This is in pico. So this first two digits we simply write here, and we can add 3 zeros at the last of this at the end of this number. So we get the capacitance value in picofarad. Okay. Then for a capacitor, so we apart from the capacitance, we have to consider the voltage as well. So you can see this capacitor is rated to 1 kilovolt. 1 kilovolt means kilo means 10 to the power 3. So it is 1000 volts. So which means we can connect this capacitor to a potential difference maximum 1000 volts. So if we connect capacitor beyond this limit, this capacitor will be damaged or it may explode. Okay. So then we are going to the polarized capacitor. So in here we have a polarization, which means like we have plus or minus, plus and minus terminals. So in these type of capacitors, the minus terminal is marked here with this strip. So if we interchange these two, then also this capacitor will be damaged or it may be explode. So the in here you can barely see here this capacitor is rated 10 volts and 2200 microfarad. So So if we get a good picture, so this is how the rating is in this type of capacitors. So the farad value is directly written here, 10,000 microfarad, and the maximum voltage is directly written here. So these type of polarized capacitors usually have less voltage rating than this non-polarized capacitors. So this all of these things are varying with the what is the dielectric medium inside this capacitor. So then if we go to diode, so diode is like a simply if we consider a simple analogy. So it is like a one-way switch or one-way valve. So if it will allow the current flow in one direction, so then it will resist the current flow in other direction. So this component also have two leads, and it will allow the current flow in the anode to cathode. So this arrow represent the current flow. This is the current flow direction. So this if we come from this side. So this denotes it is resisting the current flow. So this will only allow current from anode to cathode. So if we so this is a simple water analogy. So if water is coming from here, so this valve will allow the flow. So if the water comes from here, it will resist. So if we have to use a diode in our circuit, so first there are two main things to consider. One is the allowable current. So I will come into that in the later part. So how to select and other things. The other thing is what is the maximum reverse voltage. So if we consider this diode, so this ring will denote the cathode, and other side is anode, which is should be connected to, if you like use connecting a battery. This is the way to connect if we want to allow the current to this step. Okay, so then we go to next slide. This is I think you have already played with this component a lot. So LED, you know what is LED? I think so. This is also a diode, which means this also have two leads. One is anode and cathode. So anode should be connected to positive, and cathode should be negative. So in LEDs also, the current is flowing only in one direction, which is denoted by this arrow, and these two arrows are representing that this diode is emitting light to outside. So if we connect this LED in reverse bias, so in some cases definitely this LED will not light up, but it will in most cases it won't be damaged. But if we connect this to a higher voltage like 12 20 or something in wrong direction, this will definitely damage the LED. So there are many types of LEDs, like many colors, many shapes, and many pot ratings. Like we have like a regular small LED to 5 watt, 10 watt, 20 watt LEDs that are used in like light bulbs and flashes. So how to connect a LED to a high voltage? So high voltage means like main AC voltage. I mean, like if you want to light a LED with 12 volts. So in your task, you may have to connect LED to maybe 12 volts. So if we have a 12 volts battery and we have a LED. So if we connect this in simply, so what will happen? This LED will definitely going to explode or will be damaged, definitely. So it may light up for a millisecond, then it will be damaged. So you cannot use this LED after that. So to prevent this, that we can simply use a very basic component, a resistor here. So a resistor will control the current flowing through this circuit. So how to calculate the value of this resistor? So we know the other thing to know is someone is turned on his microphone, on his camera. So then if okay, so other thing to know about this LEDs. So the uh, recommended potential difference between these terminals in the range of 2.5 volt to 3 volt for a regular small LED, like the one you the LEDs you play with. Then if we go to a very high voltage LED like a 5 volt, 10 volt, this may be different. But usually for a normal regular LED, this is the voltage difference, the recommended voltage difference between these two terminals, and the recommended current is usually the range of 5 milliampere. That can go up to like 10 milliampere, and that is the usual limit. So if we want to calculate this R value, so you can simply like assume this is a 12 volts battery. So if we want to calculate the R, so you can simply subtract 3 volts from 12, which is 9 volts. Then you can divide this by this current, 5 milliampere. So then it is the required R value for your resistor. Okay, so I think you know about the Ohm's law. So this is one new use of Ohm's law. So this is voltage, this is current. So then we can get the required R value for a resistor. So then we move on. So this is a somewhat revolutionary and somewhat complex component. So transistor usually have 3 leads: base, collector, and emitter. I think you may know about this. Then there are 2 types of transistors, NP and PNP. So I will not go into detail about how the curves are, how these transistor curves are derived and so on. So that will be very boring. So this is a very simple analogy with water. So consider this is a transistor. So this water flow is the current. So if we consider this way, so if we cut off this water flow to this base, this door will be closed. So like in this picture. So then the current flow is cut off by this door. So if we allow water flow to the base, so it will open the gate for the collector. So then the water flow will go in this section. So that is the like basic and very simplified analogy for a transistor using as a switch. So one thing to additionally know about this transistor can be used as an amplifier and as a switch. So I will come to that later. So then there are many types and many form factors with the transistor. So you can see various types of transistor. So this type of transistors are not around anymore. This is a very old types. So we can have like this type of transistors. We can see now day to day like in electronic components. So this the shape and the form factor varies with the current flowing through this transistor. So if a transistor is rated for very high amount of current like 5 ampere, 10 ampere, so this transistor will more likely look like this one, or a very large transistor like this one. Oh, so if the current is like 2 milliampere, 200 milliampere range, the transistor will most likely look like this type. So then we'll go to the final, I think final component. So integrated type circuit. So integrated circuit is simply a circuit which is made inside the silicon chip. Like if you get IC and if you somehow remove this black housing, black casing, you will get something like this. Something like this. Okay, so this is a very good example. So it is this picture represent a regular IC where this black car housing is removed. So the inside is will be look like this. A silicon die. Silicon is made out of soil. Silicon die connected with these pins. So this die includes a very large circuit. So if we have a so for example, so if we go so okay, so this is the 4070 IC which is used in many decoration applications in private buses and TVs. So this IC will look like regular this type of form factor. So the inside circuit is something like this. This is also a very simplified version. So if we have to build this in with usual transistors and resistors, this circuit will be like in 1 square foot or large size circuit will be there. So to avoid that, so the manufacturers who can integrate this kind of very large circuit into a small die like this, they have integrated this to this type of die, and they connected this like connection to attach other components, and they sealed this die inside this black casing, and they sell this whole circuit as one single unit. So instead of making this large circuit with the IC, we can simplify and save time, space, and maybe power in most of our applications. So this is additional information. So how to find the pins? So this each IC have many number of pins, like for 8 to maybe 100, 200, 300, and so on. So each pin have a number. So in here you can see one. There are pin numbers for each pin. So how to identify that in real IC? So there will be a notch or a mark like this square, this circle. So that the nearest pin will be 1. So then this will go as in this direction, 1, 2, 3, 4, and then 5, 6, 7, 8. So that is additional information. So then battery and power supply. Since I think your competition is based on simulations, so this won't be very useful. But for to use a circuit in a reliable way, we have to use a good power supply. So that maybe can be battery or a power supply. So in here we have to consider what is the voltage that can be supplied by the power supply, and what is the current that is required for our circuit. So for example, like our circuit is like 3 volt and 100 milliampere. So we have a battery with 9 node. So then if we connect it like this circuit can be damaged. Or in the other way, so even though if we have a 3 volt battery, this battery, if this battery cannot supply 100 milliamperes, so assume like this battery can only supply 50 milliamperes, then there will be also a problem for powering up this circuit, because this circuit requires 100 milliampere. This battery only can provide 50 milliamperes. So these two basically have to be considered. Then other things, wires. I think this is not very useful in the competition. So this is the convention. So when we draw schematic diagrams, so assume like if we draw a schematic diagram like this, so there are lines that are not connected, and but they are crossing each other, and there are also lines that are connected and crossing each other. So this to denote these two types, So there are two conventions. So this is connected and not connected. So here the one wire is going above other wire. So in this convention, if this is connected, there is a dot, and not if this is not connected, and there is no dot. So other than that, if we going to use wires in actual like real circuit, so we have to consider what is the current that we want to carry using the wire. So if we use like a very thin wire for higher amount of current, this wire may be heat up and will melt this copper core. So we have to uh, think about what is the maximum current this wire we selected can carry without damaging itself. So other than that, this also additional information. So this you may also know this breadboards. So if you completed the practicals in first semester, second semester, you have to know about this definitely. So to assemble a circuit without soldering and testing it, obviously like very simple circuits, we can use this type of boards. There are many sizes, and these are the usual connections inside. So this each of this core is connected inside here like this blue one, and these rows are connected horizontally like this pink line represents. It is also true for this for lines as well. So then we can go to next section. So then when we before going to this section, so is there any questions about the first part? If you have questions, you can like quickly ask. Yadu, are there any questions?
It seems like there are no questions, so we can move on.
Okay. So the second part may be more important to you when you design a circuit. So when we design a simple like for your task, the task will be somewhat a simple one. Even though it is simple, so you have to consider how to choose a component. So there are like 100,000 million various kind of components. Like if we consider transistors, there may be million various types. So how to choose a transistor that is most suitable for our application? So I will give a basic guideline. So this is for your basic task. So for advanced high-speed task, so there are many things to consider. So then as I already told you, we can use a transistor in two modes, switch and amplifier. So for using as a amplifier, so there are basically three types of configurations: common emitter, common collector, common base. So here I have shown this is common emitter configuration. So you if you are in like first year or second year, I think you will learn this in fourth semester or third semester in our faculty. So don't worry about this very much. So this is common collector configuration. And there's another configuration course called common base. So in each I will explain with this common emitter because this is the most usually we come across this kind of configuration in our projects. Then if we consider this circuit, when this transistor, assume this transistor is closed. Closed means this terminal and this terminal is connected together. So if we use transistor in amplifier, so there are two ends for the transistor, like ends in transistor characteristic. One is saturated and one is cut off. So if you didn't learn about this yet, so don't worry. So there are two ends, saturated, cut off. This is like the two extreme ends of a transistor characteristic. So saturated means this transistor is fully turned on. Means like if we consider this emitter and this collector is connected, we can think like this is connected with the wire. Like this is a simple analogy. So this is turned on. Cut off means this is fully turned off. Which means like this, there's no connection between this collector and emitter. This is like off. So if we use the transistor as a switch, we are using in these two regions. Like if we like a regular switch, the transistor, we turn on the transistor and we turn off the transistor. If we use a transistor as amplifier, we are using the transistor in between these two regions. Like if we draw a line here, so we can use the transistor as like in this region. This like it is half turned on, half turned off. So there are many possibilities for transistor. If we use this as an amplifier, if we use this as a switch, there are only two possible options: either turn on, either turn off. So if we have to choose a transistor for an amplifier, we have to like I'm talking about the safe margin. Like assume like this amplifier handle like 1 or 2 amperes, and we put a very small transistor, and the result will be a disaster. So if we consider about the safe side, we have to consider, so what is the current moving through this line if the transistor is fully closed. Like if we connect this collector and emitter with the wire, what will be the current flowing through the transistor? That will be the maximum current flowing through this circuit. Okay, I think you can understand. Then what will be the maximum voltage if the transistor is turned off, if there is no connection between these two, this collector and emitter, the whole supply voltage will be applied between these two terminals. Okay, so then we have to consider these two basically. So other than that, if we go for amplifier, we have to consider voltage gain. That is for the gain calculation. So I don't know about whether this will come to your task, but you have to definitely learn about this in future semesters. So first thing, this we have to consider this one, this one, then emitter base voltage. Emitter base voltage means what is the voltage between these two terminals. This also we have to consider. So so I'm now talk about the amplifier. So in here we are using in these two circuits we are using the transistor as a switch. So in here also, so there are no like states in between these two. We are only consider about saturated and cutoff region. So if we give a signal, the transistor will turn on. Then these two will be connected. So then, what is the maximum current going to this line? We have to consider that. So if we turn off the transistor, so then what will be the maximum voltage between these two terminals? So we have to consider these two if we are going for either for switch and or amplifier. So then I will show with the example transistor how to find out values for these parameters. So this 2N3904 is like a general purpose transistor, which is like very widely used in basic simple circuits. So so I think you know every electronic component as a data sheet. So if you have internet, so you can simply just type the transistor number or transistor IC or whatever number and then data sheet. So then you will get the data sheet. It is simple like that. Okay. So then this data sheet have like many graphs, physical parameters, and ordering numbers, so and so on. So for a basic circuit, so we don't want those things like this. The graphs are very useful if we are using a very reliable, good amplifier. So for a basic task, we have to consider these parameters. So the first one is collector current continuous. This is given as 2 milliamperes to 200 milliamperes for this transistor. So then this values we talked before. Collector emitter voltage is given here. Collector emitter base voltage is given here. So this is these are the maximum ratings this transistor can safely operate without a problem. So considering these ratings, you can choose a transistor. So for your task, like for a simple task, the best practice is to like go for various number of transistor models and get download the data sheets and consider these parameters to choose the best one for your circuit. Then another thing, so then we are going for MOSFET. So the MOSFET also can be used as a transistor as well as a switch. MOSFET can be used as an amplifier as well as a switch. So for the MOSFET is using as amplifier is a bit too difficult. So there are many equations we have to handle. So therefore, I'm mainly focus on this MOSFET using as a switch. For that, also we have to consider what is the maximum current flowing through the MOSFET. Like if the MOSFET is used as a switch, and the MOSFET is turned on, these two will be virtually connected. Then what is the maximum current flowing through this MOSFET? We have to consider that. Then these both are saying the same thing. So then gate threshold voltage. So to turn on a MOSFET, so you have to supply a certain amount of voltage to turn a MOSFET on, fully on. So if like that voltage value is given as gate threshold voltage. So if we supply this gate terminal with the voltage less than this gate threshold voltage, this MOSFET may partially turn on, or maybe not turn on at all. So in order to sure we turn on this MOSFET, we have to supply a voltage greater than this gate threshold voltage to this gate terminal. So if we go to a general purpose MOSFET, so this is a you can maybe you maybe seen this type of components mainly in like very small devices like motherboards and such kind of circuits. So this is a MOSFET, but don't get me wrong. All of these type of devices are not MOSFETs. So other devices can also may appear like this. So this is a very general purpose MOSFET. In here, as a summary, we can have the voltage value, the resistance of the MOSFET when turned on, then maximum current. So if we go to this circuit, so the maximum current. So assume we have to conduct like 100 milliampere when our MOSFET is turned on. So we can, since this MOSFET can handle 210 milliamperes, we can use this MOSFET for our circuit. So then apart from that, so this is the voltage. So assume this MOSFET is turned on or turned off. So this connection will be not here. Then this supply voltage will appear between these two terminals. So there is a parameter maximum voltage between these two terminals. That is also given by this. So for this model, so we can have 60 volts to 60 volts between drain and source terminals without damaging this MOSFET. So then this turned on resistance that is not very important for simple tasks. So even though this I told you that when the MOSFET is turned on, we can simply consider these two terminals connected with wire. So there will be a small resistance between these two terminals even the device is turned on. So that resistance is given uh, in here. So this is the maximum current that can handle. Then if we go to this table, so this is given as weight threshold voltage. So for this model, we have to apply at least on this MOSFET for conducting. Then finally, we can go to diodes. So if we are using diodes in any part of our circuit, we have to consider two things. First one is maximum current. So as I told you earlier, diode conducts current in only one direction, this direction. So when this is happening, so there is a limit for the maximum current that can flow through a diode. So if we go to, for example, this is a very general purpose, excuse me. Oh, this is a very general purpose diode. You can see these diodes in inside your phone chargers, CFL bulbs, and many other things. This is how very general purpose. This is a data sheet for this whole series of diodes. This data sheet for this all of these diodes models. Then we go here. We have maximum forward current. So each of these diode can conduct maximum 1 ampere when forward biased without damaging itself. So this is the maximum forward current. So this is what is this reverse voltage? This reverse voltage means so if we apply a voltage in this direction, this diode will be turned off and there will be no current flowing in this direction. But if we increase this voltage after some value, this resistance will be break down and the current will start to flow in this direction as well. So that will be will definitely damage a normal diode. Okay, so this voltage value, so this voltage value is required to break this resistance in this reverse direction is given as this reverse voltage. So we go to the data sheet. So for each model, like 4001, 4002, so on, this this maximum repetitive peak reverse voltage. So this is given 50, 100, 200, up to 1000. So if consider we have in in a scenario, our one diode in our circuit will we have to face 100 volts in reverse direction. So if we use like this diode model, the maximum value is 50. So when 100 volts are applied, this barrier, like the resistance for the reverse direction, will be break down, and the current will start to flow in this direction, and additionally this component will be damaged. So we have to consider about this as well. So if we go to for example like this, so you may know about this configuration. This is a diode bridge with full wave rectification. In here, like assume we connect this to our main supply. So this is 230 volt, but this 230 volts is the RMS value. So the maximum voltage. So you know about the main supply voltage. It will be like a sine wave. So the average value is the RMS value is 230 volts. The peak value is 230 by root 2. This is the peak value. So if so since this is connected to 230, each of these diode have to face 230 by root 2 voltage in reverse direction. So that will be like 300 to something, 300 something. Then we cannot use these three diodes. These three diodes for this type of circuit because each of these have a smaller reverse voltage value. So with that, since the 1 hour is over, so I think that will be the end of my introduction. So, Pato?
Yes.
Okay, so can we go to the Q&A? So I think they may have questions. We don't know. So can we go to Q&A?
Yeah. Is Uma there?
Yes. Sorry for the delay. So thanks a lot for your commitment, sir. And I'm sure our audience got the maximum out of the content that you shared with us today. So if anyone in the audience needs any further clarification, you can raise your questions to our speaker, or else you can use the chat box.
So since like the allocated time
No.
is 1 hour.
Excuse me.
So Okay.
There's a question.
Okay.
Yeah, it asks, sir, can you briefly explain about the watt value of the resistor?
What value? Okay.
Yeah, what?
So what value? Then so if we use a resistor, then okay. So assume we are connecting a 12-volt battery to a 1 ohm resistor. So as you know, using the ohm law, we can get the current flowing through this resistor, which is voltage divided by resistance is 12 ampere. Okay. So then what is the power dissipated by the this resistor? So you I think you know, but power equals voltage times current. So this voltage is 12, current is 12. So the this resistor is dissipating 144 watts of energy. If then, so this type of like very small resistors, they are rated for half watt or maybe 1 watt or maximum 1 watt. So if we use 1 ohm, this type of resistor in here, what will happen? Of course, this can conduct the 12 amperes, but this will heat up so fast and this will burn out like in a very for in 1 second or so. Then we can use this resistor, but we cannot continuously use this resistor for this type of high current. So therefore, we have to have a resistor which can safely dissipate 144 watts without damaging itself. So therefore, we cannot use this half watt or 5 watt resistor for this circuit. Okay, so there's no problem with the ohms value. The problem is we cannot continuously use this resistor for this circuit without damaging it. I think it is clear.
Yes, sir. Your answer was very clear to us. There's another question in the chat box. Says, sir, is the blocking voltage the same as the reverse voltage?
I think he's referring to diode. I think blocking voltage. Oh yes, voltage. So I think he's referring to diode. So yes, blocking voltage means how much voltage a diode can block in reverse polarity direction. So that is same as this reverse voltage. That is the for these two terms have same meaning, but just two words. So you can simply get. So say some data sheets may indicate like this maximum peak reverse voltage, or some old data sheets they are maybe high maximum blocking voltage and so on. So that is that these two are same.
Thank you, sir.
I think there are no more questions, so we can move on.
Yeah. it seems there are no more questions, we'll move to the next item. Next, I'd like to invite Mr. Hashitha Gunawardana to accept the token of appreciation for his valuable time and effort spent on behalf of us.
Thank you.
Okay, thank you, sir. So next, we are going to have a group photo. So those who are comfortable with, you can switch on your cameras and join us. There you can use the virtual background we have sent to the chat box. And I'd like to remind you that you may have to keep your cameras on for a few minutes as we have several screens to take. So we have to take multiple screenshots.
Okay, thank you. Thank you.
Okay, thank you. Now we are moving on to the quiz. As I mentioned you earlier, there would be altogether 5 quizzes in this workshop series. By completing 4 out of them, you can win an e-certificate for completion of the workshop series, while printed certificates will be given to the top 3 scorers. So let's move to the quiz. The link will be sent to the chat box. You will be given 10 minutes to complete it. So your time starts now. it's a kind reminder for the audience. You have only 2 more minutes. So all of you are requested to submit your answers. So we are going to close the quiz. So you have to submit your answers. Actually, at 8:30, we are going to close the quiz. All of you have to submit your answers now. So the quiz is over now. Thank you all for your kind participation. With that, we've come to the end of the first workshop of our SparkLink 1.0. Hope to meet you again in our next workshop tomorrow. Good night to all.